So in presence of your concentrated NaOH, what is going to happen? Okay, you have to keep this point also in mind because many times questions are directly asked based on this part also. Hydride can only attach over here. We will see why very soon. So hello my dear student, how are you all? So I welcome you all to Alan Overseas. So as you know, we are doing 45 days challenge. In 45 days, we are going to cover 45 topics. And over here, you can see the distribution of your topic according to subject, physics, chemistry, maths. And today, we are going to do one of the important topic of your chemistry, which is your Cannizzaro reaction, which is from your name reaction part. And this is very important for all of those students who are preparing for JEE Mains. So without any delay, let's start with our Cannizzaro's reaction. So for Cannizzaro reaction, the important thing which you have to keep in mind is its mechanism. If you know its mechanism, because the most of the question which will be asked to you based on your Cannizzaro reaction is from your mechanism. So if you know the mechanism, then the Cannizzaro reaction will be very easy for you. So we are going to see its mechanism. But to understand the mechanism, the first thing that you should know its actual definition. So what's its definition? Definition says an aldehyde which do not have, this is important part, which do not have alpha hydrogen atom. So if in an aldehyde, if there is no alpha hydrogen, then this undergoes self-oxidation and reduction, means disproportionation reaction on heating with concentrated alkali. We usually use concentrated NaOH or KOH. In most of the scenario, you will see this two only. So basically, the aldehyde which do not have an alpha hydrogen, only those aldehyde can perform your Cannizzaro reaction. Sir, then what about which have an alpha hydrogen? So we have already seen a reaction, like there are many reactions. If there is an alpha hydrogen, what is going to happen in that scenario? But over here, the important part for us is, if a aldehyde, if it do not have an alpha hydrogen, then we are going to perform our Cannizzaro's reaction. And how actually it is done? Let's see that part. So these two are your aldehyde. And is there any alpha hydrogen? No, there is no alpha hydrogen. So in presence of your concentrated NaOH, what is going to happen? This is going to give what you can say Cannizzaro's reaction, and this two will be the products. And what are the products? So over here you can say the product of the Cannizzaro reaction are your salt of your carboxylic acid and your alcohol. So these two products are formed. But sir, how actually they are formed? So let's see that part. So if this is given to you, the first step will be the rapid reversible addition of OH minus to one of the molecule of your aldehyde. So from here, what actually you can get? From the ion, you can get Na plus and OH minus. So the first step is a rapid reversible addition of your OH minus. So over here, what we are going to take? This part will be there. So we are going to take one aldehyde first and this OH minus. Now this OH minus is going to attack over here. Why? Because obviously there will be partial negative charge over here and partial positive charge. So over here, this is going to come and attack over here. And what will be the product? Because if this is coming over here, then this will go upside. So over here, this will be the product. This will come and attach over here. And this one pair will go up above and there will be a negative charge. So this is the part which we are going to get. Now, the next thing, once we get this, so over here, you have to keep in mind, this is a reversible addition of OH minus, but because the concentration of your OH minus, like because it is in concentrated NaOH, so the concentration of OH minus will be high. So that's why I can say this reaction will only move forward because of the high concentration of your OH minus. Okay, so once we get this, so then what's about this another aldehyde? What we are going to do about that? Or what is going to happen next? Let's see that part. So now there are two things, which is, one is that like over here, this can again leave and we will again get this part only. But if you don't want to go backside and if you want to like proceed further, what we have to do? We have to remove one hydrogen which is connected to your carbon like this. So let's see your second step. So transfer of your hydride ion H minus. Many students have this doubt, like obviously whenever we perform this reaction, whenever we remove the hydrogen, we usually remove H plus. But this is not the case in this scenario. Over here, we are going to remove our hydride ion. Hydride ion means the two electrons which are present over here. These two electrons will be taken by this hydrogen ion over here, and this will be your hydride ion. like this will be your H minus over here, which will be removed. But if you remember, it is going to remove and it will go where? So if you remember, in the beginning we had 2 aldehyde. So we have only got this part from your one aldehyde, and now we are going to use another aldehyde. Let's see, like this. And what is going to happen? This is going to be removed and this will go to this carbon. And if this is removed, then what can happen? This charge which is present, this can come back and this charge will go upside. Then what will be the product in this scenario? So over here, if this is going to come back, so there will be double bond. This is removed. So instead of over here, I can write OH minus just for our looking part. So this part, first part will be this, and the second part will be this. How? Because this hydrogen is going to come and attach over here, and this, like you can say double bond, like 2 electrons will go upside, and over here there will be O minus. So like this, the product is going to be formed. But is this your final product? No. Now over here, as soon as you got this, next third step will be your proton exchange. So what is your proton exchange? Let's see that part. And one more thing over here which you have to keep in mind, the hydrogen which is actually removed over here, it is a very poor living group. And because it's a very poor living group, so this step becomes the rate determining step, because this will be your slow step. Okay, you have to keep this point also in mind, because many times questions are directly asked based on this part also. Okay, so now the next. Once we have this, now there will be your proton exchange. How actually your proton exchange is going to happen? This hydrogen which you see over here, this will be transferred to this part. Okay. So now the compound will look something like this. So this will be removed. So there will be O minus, and over here this will be directly an alcohol. This part will be your directly alcohol. So if you remember, when we were doing our Cannizzaro reaction, we got 2 things. One was your alcohol and another was your salt of your carboxylic acid. So now we have this part, but sir, how actually we can make this salt? So if you remember, in the beginning we used concentrated NaOH. So from your NaOH, you are going to get Na plus and OH minus. So we have already used this part. Now this is left with us in the solution. So we can directly add this over here like this. We can add this and we can get this product over here. And what is this? This is nothing but the salt of your carboxylic acid. So in short, I can say the product of your Cannizzaro reactions are salt of your carboxylic acid and your alcohol. So in short, the first reaction which we wrote is true, and now we understood its mechanism also, how the Cannizzaro's reaction mechanism work, and how like the Cannizzaro reaction products are your salt of your carboxylic acid and the alcohol, and how actually we are going to get this 2 product. We have understood its mechanism in detail. So now let's see a few important note points which are very important. Like if you remember, I told also this, which is the hydride ion H minus is a poor living group. So the step where the hydride ion is transferred from one aldehyde and attack on another is the slowest, and hence it is the rate determining step. Like that step is the slowest step. That's why we call that step as a rate determining step. So now we understood this. So we can also write one more point which says this means that the speed of overall reaction is limited by the speed of this step, the rate determining step. And based on this, we can find the order of your Cannizzaro's reaction, and the order of the Cannizzaro's reaction is order 3. These 3 points are very important point which you have to keep in mind. So because many times directly questions are asked from this, so you have to keep this in mind. Now once we know this, we can jump to this question. So over here, if you will see there, so this 2 part we have already done, but over here there's something different. Yes. So instead of your NaOH, there is OD. Instead of your hydrogen, we are using its heavier version, which is your D. So OD. In this situation also, there will be Na plus and OD minus release. But over here, in this situation, instead of your OH, your OD is going to attack one of your aldehyde. And now how actually your product is going to change? Let's see that part in detail. So that's why I told you the mechanism part was important, because once you know the mechanism, now you can easily perform this type of the reactions and you can write that product very easily. Let's see that part. So obviously this is going to be there, and now this is going to attack over here and this will go upside. Yes, this part we have just seen. So over here we can directly write this. So if this is coming over here and this is going above, so obviously this will be our product. Now to do like go further, obviously we are going to remove one of your hydrides like this. So now over here, this we have already used one aldehyde. Now we are going to use another aldehyde, and over here there will be your hydride transfer. This will go and it will attack over here, and this will come down and this will go up. So we have just seen this. Yes, we have just seen this in the previous slides also. Now this is going to jump above. Now this will be the product. So because this is coming down and this is leaving, this part will be there and there will be this. Now if you remember, there was a proton exchange. So now this proton which is present over here, this will be exchanged and this will be transferred over here. And if you will see how actually D is changing its position, and that's why this type of the questions are given to you, because you have to, like, the options will be given to you and the position of the D will be changed. And in that situation, you have to understand where actually the position of D is there and which is the correct answer. So like in this situation, like once you are at this, so you are going to transfer the D will come over here, and over here you will be left with your carboxylic. Like once you add your Na plus, you are going to get your carboxylic salt over here. Just see. Over here you can add your Na plus. This will be your carboxylic salt which can be directly added over here. So over here I can write this as HC double bond O, ONA plus HCH and your OD. This will be your final product. So like this we can solve this type of the question if they are asked. So now let's see the next question. So in this question, what is given to us? Write the product in the following reaction. So if you are given with this, so now you don't have to go with the mechanism again and again. You can directly write the answer. How? Because now we know there will be, like, if you remember, if this question is given, but sir, we use 2 aldehydes and those aldehydes should be, like, those aldehydes shouldn't have your alpha hydrogen. In that situation only we can perform your Cannizzaro reaction. So let's see if that is given or not. So over here, obviously concentrated NaOH is given. Now over here, aldehyde is given. There is no alpha hydrogen. And over here also, if you will see, there is no alpha hydrogen present. That's why this reaction can give you Cannizzaro's reaction. And over here, if you remember, we use 2 aldehyde to get our product. So if it is not even mentioned in the question, in that situation also, we are going to take it as twice, because this is given in the solution part. So they will be present in a lot. So we are going to use 2 of this compound, and the product which will be formed over here will be the salt of carboxylic acid and the alcohol. So over here, just remove this and add ONA, because over here there is Na. That's why ONA, this is your carboxylic salt and this is your alcohol. So instead, just remove this and write alcohol over there. And like this, we can write our product. So this is how we can write the question, and this is how we can perform the reaction. We can directly write the answers. So now let's see the next question. So in this question, what is given to us? Let's see. So you are given with this part and they told us write the product in the following reaction. So if you want to write the product in the following reaction, so firstly over here there's concentrated NaOH. So it means I can perform our Cannizzaro's reaction, but you have to check whether there is an alpha hydrogen present or not. If there is no alpha hydrogen, I can easily perform our Cannizzaro's reaction and I can write our product. Obviously there is no alpha hydrogen present. So what actually I can write? I can write firstly it's carboxylic salt, and the next one is the alcohol. So over here, just replace this H with ONA, because there is Na. You are going to get the salt of your what you can say salt of your carboxylic acid, and in the next part just add alcohol and 2H, and you are going to get your alcohol part over here. So we can easily do this reaction in presence of your concentrated NaOH. And remember this part, because there is Na, that's why we are writing Na over here. If there is KOH in that situation, there will be K over here. Okay, so now once we are done with this question, let's proceed with our next question, which is this. So over here the question says, Cannizzaro's reaction is exhibited by which of the following 4? So the again and again I'm telling you this part, which is just see whether there is an alpha hydrogen present or not, and don't get confused with their like name. They are very easy. Just write it. So what's the A? A is C double bond O, H and H. What is your B? B is your C double bond O, H and CH3. What is your C over here? C over here is C double bond O, H. There is CH2 and then there is CH3. And what is your D? In the D, if you will see, there is again C double bond O, H and there is CH2, and then CH3, CH2, and then CH3. So this part is there. Now over here, once you have this, now you can easily identify which of the following of the molecule do not have your alpha hydrogen, because if they have alpha hydrogen, in that situation they cannot give Cannizzaro's reaction. So obviously this part over here, this cannot give because there's an alpha hydrogen. This also have alpha hydrogen, this also have alpha hydrogen. So this 3 cannot give. Obviously this one can give this, and we have been doing example based on this only. So once we know this, we can easily do the question if they are asked based on our Cannizzaro's reaction. So now let's see the next part, which is your cross Cannizzaro's reaction. So what about this? What we have to do in this? So if you remember from the previous part, if we have only using the same kind of aldehyde to do our Cannizzaro's reaction, but when we use 2 different type of aldehyde to do Cannizzaro's reaction, this is called as cross Cannizzaro's reaction. So obviously over here, first thing, there will be Na plus and OH minus. This OH minus will be attacking onto this part over here. Just see mechanism part. So this will be attacking. How actually it will attack? This will go and this will go above. Yes, this part we already know. So what will be the product? In this situation, the product will be directly going to attach over here, and this is how it is going to be look. So this is directly attacking over here and attach over here. So once we have this, now what is also present in your compound? This part is also present. So from the first part we got this, and now we have to shift our hydride. Like if this goes, again you are going to get the reverse part. But if you want to proceed next, we have to transfer our hydride. So hydride can only attach over here. We will see why very soon. So over here we are going to use this part, and hydride is going to come and attack over here. Yes, how actually it was attacking in the previous part. But in previous questions over here, both were same. Now because it is different, that's why we use cross, like we tell this as a cross Cannizzaro's reaction or mixed Cannizzaro reaction also. Okay. So once we have this, over here the note which you have to keep in mind, which is in a crossed Cannizzaro reaction, the more reactive aldehyde is oxidized to the carboxylic acid, and the less reactive aldehyde is reduced to the primary alcohol. This part you have to keep in mind. So what's the important point over here? Like more reactive aldehyde is oxidized to the carboxylic acid, and the less reactive aldehyde is reduced to the primary alcohol. So based on this, because this is that, there is a bulky group also present. That's why this hydride is going to come and attack over here. Because this is going to attack over here, what is going to happen? Like this hydride will come and attach over here, and this is going to look. So this will go above like this. And what will be left over here? Obviously, because this is going outside, so this will come down, and this is going to look like your alcohol. Like H is there, carbon, there's double bond O, and this is your OH minus. So this is what we got. But if you want to get this, we have to change, or you have to transfer your proton from here to here. So obviously we are going to get this part only. Can you see? And that's why this is written like in crossed Cannizzaro reaction, the more reactive aldehyde is oxidized to your carboxylic acid. So over here, this part will be your carboxylic acid, because this is your more reactive, because there is no bulky group present. That's why it is more reactive. Whereas over here, there is a bulky group present, like in this situation. That's why this is your less reactive, and that's why it is written like the less reactive aldehyde is reduced to the primary alcohol. Okay. So I think so everyone understood. And like over here, if you add Na plus, you are going to get your carboxylic acid salt. So like this was your cross Cannizzaro's reaction. So now let's see the next part, which is your intramolecular Cannizzaro's reaction. Over here, if you will see that like the 2 aldehyde are present in the same molecule, and over here also we can do our Cannizzaro's reaction. Like same thing will be done. Like this is our single group present. Like previously we were using 2 aldehyde group to perform our reaction, and then we were getting our answer. Over here the same is there. Obviously we have to use our concentrated NaOH. So there is Na plus and OH minus. From here you are getting your Na plus, and OH minus is actually reacted. So firstly, for the mechanism part, we are going to use this and our OH minus. So this and plus OH minus. So like in this situation, because both are symmetrical from here, so either I can attack over here also or over here also. There is no problem. So in this situation, if I attack onto this side like this, if we are attacking over here, like from here, if we attack over here, what is going to happen? This will go upside, and this is how this compound is going to look. There is this hydrogen, now this carbon, this is O minus, this is exactly the same, and this OH has attached over here. Once we got this part, what was the next part? It was the transfer of your hydride. Now how actually we are going to do this? So now once we have this part, so what I have done, I have just changed their position so that it is easier for us to transfer the hydride, like to show me. So over here, I'm going to transfer this. So this is going to upside and this will go below. So the next I can write over here, like this whole thing is transferred. So the next thing I can write is like this. So this will be there. This is transferred to this. So this will come below and this will go upside. Once we have this, now we have to transfer our proton. So this hydrogen over here will be transferred to this side like this. There will be proton transfer. This will be transferred to this side. So this is how it is going to look. There will be O minus, C double bond O, C, OH, H and H. And over here, we can write our Na plus, and that's why we are getting this product over here. Yes, you can see CH2, which is this part. There's OH, C double bond O. And what is this? This is your intramolecular Cannizzaro's reaction. Like this, we can perform different type of Cannizzaro's reaction. The only thing which you have to keep in mind is the mechanism, because once you know the mechanism, you can easily write the product. And many times they will directly tell you, like give you like this, and they will tell you which of the following four are the answer, or which of the following four are the product for the given reaction. So in that situation, you should know how to perform this reaction, or what's the mechanism, so that you can easily write its answer. So now over here, like this will be your final answer, like I was telling you. Now let's see a question, and this is your JEE Mains 2013 question which have been asked. What does this question says? Cannizzaro's reaction is not given by. So over here, this word is important, not given by. So it is actually given by those which do not have alpha hydrogen. So if there is an alpha hydrogen present, it means that type of molecule is not going to give your Cannizzaro's reaction. So just see that part. So firstly, to write its answer, first part only I can write, which is this, which is C double bond O H CH3. There is an alpha hydrogen present. There is an alpha hydrogen present. That's why this will be directly my answer, because the question says Cannizzaro reaction is not given by if there is an alpha hydrogen present. So obviously my correct answer is A first only, but let's check another part. What is this? Second one is your C double bond H. Obviously there is no alpha hydrogen. So this is going to give Cannizzaro's reaction, but this will be not my answer. Again over here, C double bond O, there is no alpha hydrogen present. That's why this is going to give Cannizzaro's reaction. Again over here, there will be double bond over here. So again, there is no alpha hydrogen present. That's why this is going to give your Cannizzaro's reaction. That's why this is not my answer. So over here, we have done a question from your JEE Mains, which is very easy. You can easily, like I just explained you, but within seconds, you can easily solve this question. So like even just by seeing this, if you know the concept, you can easily solve the question. So that's all from my side. Like over here also, you can see its answer. The correct answer is your option 1. So that's all from my side onto this topic. So if there is any doubt or any suggestion for us, you can just go to the comment box. And if you want to watch the whole playlist, you can just see that in the description box. So stay tuned with us. Thank you.